Hello, everyone. Today we will be discussing how mRNA gets translated into proteins using the analogy of writing and performing a modern adaptation of Hamlet by Shakespeare. So here we have a template strand and a coding strand of DNA. But which do we use to make the mRNA? You can think of the template strand as the original Hamlet script. It is this strand that we will read to write our adaptation, and it is this strand that the RNA polymerase reads to produce the mRNA strand through transcription. The coding strand is like the no fear Shakespeare version of Hamlet. It has the same content as the original script, but it is much closer to the modern adaptation of Hamlet that we are writing. This means that the coding strand will have a sequence equivalent to the mRNA sequence. The only difference is the use of thymine instead of uracil. Here we are using our coding strand, the no fear Shakespeare Hamlet, as a guide to write our modern adaptation of Hamlet, which is then performed. But how does that work in a genetic sense? Well, here we have the same coding strand as before, but reversed so that it can be easily read from 5' to 3'. It is transcribed into mRNA, which is then translated into an amino acid sequence. Sometimes there are typos in a script or an actor forgets one of their lines. As you can imagine, this impacts the final performance of the play. Similarly, point mutations in DNA can affect the final amino acid sequence and protein end product. I've created 4 point mutations in our original DNA strand to illustrate the different effects these mutations can have. In this first mutation, a T has been changed to our C. In our final amino acid sequence, this has caused the valine to be replaced with alanine. Thus, the point mutation is a transition and results in a missense mutation. Next, we have a C being replaced with an A. This mutation does not cause a change in the amino acid sequence because the codons GUC and GUA both code for valine. The point mutation is a transversion and results in a silent mutation. Next, an A within the stop codon has been replaced with a C. UCA is not a stop codon, so additional amino acids not included in the wild-type sequence are added. The point mutation is a transversion and results in a read-through mutation. Lastly, an A has been replaced with a T, creating the codon UAG, which is a stop codon. This causes translation to stop early, resulting in a shorter amino acid sequence. The point mutation is a transversion and results in a nonsense mutation. All 4 of these mutations alter the amino acids and protein end product, similarly to how a typo in a script or a forgotten line alters the final performance. Sometimes the mistake is not important or noticeable to the audience, but other times it can have large consequences. Thank you for your attention. Here are my references.